Now see, examine the continuity of this type of a question. The second question is this type of a question I have already done in your limit form. I've already done this question in your limit form. I've already done this question in your limit form. First find the limit, that is the right hand limit and the left hand limit. See whether the limits are equal or not. If the limits are equal, then you see at x equal to a whether it is the function at x is equal to a. The value of the function here is, just a minute. Yes, x is equal to a. The value of the function here is this. So if the limit both exist and the value of the limit and the value of the function comes out to be same, then the function is continuous. In this case, you have already seen that. In this case, we had the limit problem which I did in the earlier video. I got the limit right hand limit as +1 and left hand limit as -1, which are not equal. Since the limit does not exist, this function is not continuous. Now let's see this one. I have already done this question in limit. You first find out the limit, the left hand limit and the right hand limit. The right hand limit and left hand limit came out to be 10, and the value at x equal to 5 is 10. Let me tell you what I'm trying to say. See, what I'm trying to say, let's take this third question. If you take the third question, first you will have to write limit x tending to 5 plus, this is the right hand limit. This is the way you will proceed. Right, 5 plus fx. Fx is x square minus 25 by x minus 5. This comes out to be x square limit, wait a minute, limit x tending to 5. You have x square minus 5 square upon x minus 5. This a square minus b square. So limit x tending to 5 plus, sorry. X tending to 5 plus, you have x plus 5, x minus 5, and then you have x minus 5. You cancel this 2 and put the limit, you will get 10. Similarly, in the left hand limit, proceed in this way. Just replace this plus sign with a minus sign on the top with a minus. The procedure all is same. You will again get, in this case also you will get x minus 5 equal to 10. So the limit exists, and the limit value is the limit value of this x square minus 25 by x minus 5. This comes out to be 10. And see, add the value 5. You add the value 5. F of 5 comes out to be your 10. So limit x tending to 5, x square minus 25 by 5, x minus 5 is 10, which is equal to f of 5. So this is continuous. This is the way you will do. This is not continuous because I showed you this is plus 1 and minus 1. The limit does not exist. The continuity does not come. In this also, the limit does not exist because when you take the limit extending to a plus, wait, let me now rub this all. Wait a minute. Rub this all. Yes. Yes. Now, if I rub all this, now if I talk about, let's say, this one, limit this one I'm talking about. Okay, I'll not talk. Okay, I'll talk. Okay, I'll talk with this first. Limit x tending to a plus. This is the right hand limit. Mod x minus a upon x minus a. You know that x minus a is equal to x minus a for x greater than equal to a, and it's equal to minus x minus a for x less than a. So this will be x minus a limit x tending to a plus x minus a, both brackets cancel out, gives you 1. Limit x tending to a minus mod x minus a upon, this is bracket, sorry, x minus a bracket. This will give you limit x tending to a minus, let me rub this one. So now you have this as x minus of x minus a upon x minus a cancels out, minus 1. Since limit x tending to a plus fx is not equal to limit x tending to a minus fx, so limit does not exist. Limit x tending to a fx does not exist. So fx is not CTS, not continuous. I'm writing CTS, you will write continuous completely. This is the way you will do it. Now let's see. Wait a minute. Let me take this, rub this on. Delete all this. Now let's come to this point. This point is over. Now let's come to this question. The second question. See, you have already seen this. Fx equal to, this is a fractional part of x. X, uh, this is, let me do it straight away instead of writing all this. Wait, this is at, I have to find at 2. So limit x tending to 2 plus, you write x and floor function. I hope you remember the floor function. This is that thing. So limit h tending to 0, 2 plus h and minus 2 plus h. Wait a minute. 2 plus h. It is 2 plus h. 2 plus h. So this comes out to be limit h tending to 0. This comes out to be 2 plus h as it is. Remember, 2 plus h means draw the ladder. Always draw a ladder. This is 2 and 3. 2 plus h. 2, it is between 2 and 3. देखो 2 plus h है ना, 2 से ज़्यादा है पर 3 से कम है, somewhere here, and it is somewhere here. So this will be 2. This will give you answer 2. देखो ये 3 और 2 के बीच में है. It is between 3 and 2. It is a floor function. So it will come to 2 because it will come to the floor. देखो ये 2 और 3 के बीच में फ्लोर, ये 2 और 3 का जो फ्लोर क्या है, लैडर का, ये फ्लोर है इसका, ये फ्लोर है इसका. तो ये 2 देगा. जैसे ये 2 देगा, as soon as this 2 and this 2 will cancel out. So limit h tending to 0, 0, h will give me 0. And let's see limit x tending to 2 minus x this. Now when you write limit h tending to 0, 2 minus h minus floor function, yeah, what you call the greatest integer function, this 2 plus h, 2 minus h. Now you see, again draw the ladder. Again draw the ladder, wait, again draw the ladder here. This is equal to limit h tending to 0, 2 minus h minus, now you draw the ladder. 2 minus h means it is between 2 and 1. 2 से कम, 1 से ज़्यादा. It is less than 2 but more than 1. So it will come to the floor. ये floor पे आएगा, 1 पे आएगा. So this will give me 1. And let us now do the subtraction. This will give me limit h tending to 0, 1 minus h. Take the limit, I'll getting 1. So the limit does not exist. So the function is not continuous. So the function is not continuous. This is the way you will have to do. Let me do the third one. Let me do the third one for you. Wait. Wait. Wait, let's do the third one. Achha, now the third one is, third one, I've already told you how to deal this. Limit x tending to 0 plus, I'm taking the right hand limit, sine greatest integer, sine upon x, greatest integer function, floor function, remember. Now for x, I've done this problem in limit, you have seen it. For x greater than 0, sine x is less than x. So sine x upon x is less than 1. So greatest integer sine x upon x, this is the floor function, that is between, this is your ladder, 1 and 0. एक और 0 के बीच में आएगा. कोई भी पॉइंट आएगा 0 से बड़ा, 1 से कम, greater than 0, less than 1. तो floor function will give me 0. This will straight away give me 0. This is 0 basically, less than 1, correct? Because this will give me floor this. So limit here is this. Now see about limit 0 plus 0 minus. Let us see about 0 minus. Just change this here. I've explained you that problem there very well with an example, sine 90 and 90 degree. So in that case also, for 0 minus it will be this. Fine. The rest all procedure is, but only change will be here. Only change will be here. Less than 0. Why is this? I've told you. You take sine minus 90 and you take minus 90. That is pi by 2. Sorry. Let me write pi by 2. Wait a minute. Let me write pi by 2. This is pi by 2. Pi by 2 and pi by 2. Sine pi by 2 is minus 1. And pi by 2 is minus, that is 3.14 by 2. That is 1.5 something it is. So minus, this is greater. This is greater than this. Now if you do do a multiply both sides with minus. So see, minus 1 is greater than this. So if you do with the minus, the 1.5, so this 1.5 is greater than 1. So that's why this condition. Again, I'll get a 0. That means, let me now rub all this, rub all this, rub all this, and now see what I'm going to do. Now the point is what to do. Now see what to do. Limit x tending to 0 plus, also I got sine x upon x equal to 0. So limit exists. Since limit x tending to 0 plus fx, this is that fx, is equal to limit x tending to 0 minus fx. When the function is this only, na? This is the function. This is the function. So you have limit x tending to 0 plus 0 fx is equal to how much? 0. But this is what it is given here, 1. But f of 0 is what? 1. So limit x tending to 0 fx is not equal to f of 0. So fx is not CTS, continuous. You will write the full word continuous. I hope you have understood this one also. Okay, fine. Now let's rub this. Let's ask now take the next one. Wait a minute. Let me remove this portion. Let me remove this portion. Wait. Yes, let's remove this portion. Yes. Now you can see this question. This one. Let us say, which one should I take? I'll take your which question? I'll take now. Either I'll take this or I'll take this one. Wait, let me see which one should I take for you guys. This is, let's take this function. Limit x tending to 0 plus 0 extending to, wait a minute, extending to 0 plus 0 plus, I will take 1 plus 2x to the power of 1 upon x. Now I tell you one thing. See, put this as, now you have put this limit. You can write here this, put 1 upon x as t. So 1 upon x goes to 0, it goes to 0 plus. Limit x t goes to 0 plus. So 1 upon 2 by t to the power of t, it will give me e square. What formula it is? I hope you remember. Now you take limit x tending to 0 minus, and you will get, I think, let's see just a minute, let me see the question first. Let me see the question. Wait, what are they asking? Oh, they are asking for what value of k. See, this is they are asking. That means this is continuous. I have to take this first, though I'll take it. At 0 it is continuous. So that similarly I'll do this one also. 1 plus 2x to the power of 1 upon x. Again I take x going to t. Limit t going to your 0 minus 1 plus 2 by t to the power of t is again e square. Both are same. Both are same. No problem. And they are saying also, I have to just find the value of c, so the function is continuous. So the right hand limit and left hand limit has come to be same. So the function is already continuous. I have just to find for what value of k, this function will become continuous. For what value of k this, for what value of k will this function be continuous? Already the function is continuous, you can see. So I've showed you how to find the limit in this case. मैंने दिखा दिया लिमिट कैसे निकालना है. ये हो गया RHL, ये हो गया LHL, ये हो गया LHL. This is the LHL and this is the RHL. Both are same. Now do one thing. Let me remove this portion completely so that I can get some space here only. Wait a minute. Yes. Now see. Already I have found out. Wait a minute. Already I have found out that limit x tending to 0 plus fx is equal to limit extending to 0 minus fx is already e square right now. मुझे already मिल चुका है e square. अब f of 0 पे क्या दे रखा है? At f of 0 what it is given? E to the power of 4k minus 1, right? So since the function as given fx is continuous, cds, find k. Basically it actually wants to make you find k. So as rather we should say, in order to make this function continuous, wait in order to make this function continuous, in order, let's write this way, in order to make fx continuous, fx cds, so the right hand limit 0 plus fx should be equal to limit x tending to 0 minus fx, and this should be equal to f at 0. That means e square is equal to e to the power of 4k plus 1. Basically you can write these two like this also, or you can write like this also. Limit x tending to 0 fx is equal to f of 0, because the left hand and the right hand limit are same, so the limit will exist, and that limit is how much? That limit is how much? Wait, that limit is already we found out. हमने already निकाल दिया e square. चाहे ये वाला line use करो, or you use this line. E square is e to the power of 4k plus minus 1. Now you already know that this is your bases are same. Indices rule of class 10th, 4, 5, 8 and 9. This is this, no problem. Now you have 3 is equal to 4k, and gives you k equal to k equal to this is 3 by 4. You have got it, 3 by 4. K equal to 3 by 4. This is the way you do it. This is the way you do this question. Now this you do it on your own. This one the second one you do it on your own. Similarly, exactly like this. Copy the method properly. I mean, copy the steps, not the method. Yeah, method only. Now they're asking me to find a relation between a and b so that this function is continuous. So already I'll take that the right hand limit and left hand limit. I have to use this concept now. See, here I used this concept, and I also used this concept. ये दोनों concept use किया, या तो ये use किया, या तो see ये और लिखा हुआ है ना, this or is written here. I use this concept. Now I will use only this concept. Why? Because the problem is plus of 2 and minus less than 2 here, less than 2 here. Wait a minute, less than 2 here, and you have greater than 2 here. In this portion you have greater than 2, and in this portion less than 2. So I'll use this method now. This will make things easier for me to find this relation. Now see how to do this. You see this. Now you see how to do this one. Wait, let's delete this whole picture. Wait, let's delete it. Okay, gone. Let us now come down, take some more space. Oh, I went very fast. And let us now take this. Yes, now you take this one. I'm talking about the fifth one. Fifth, limit x tending to 0 plus 2 plus, sorry, not 0, it is 2 here, sorry, it's 2 plus greater than 2. You take this function 2ax plus b, put the value, that is 2a2 in plus b, so this will be 4a plus b. Done, one part is done. Limit x tending to 2 minus ax square b. For less than 2 you will have to take this portion of the function ax square plus b. This will be a 2 whole square plus b. This will give me 4a plus b. Left hand limit and right hand limit are same. Now at f at 2, it is coming out to be 2. Now they are asking me to find a relation when the function is continuous. As given, function is continuous. In order to make it continuous. In order to make it continuous, in order to make fx continuous, cts, so I'll do is limit, both are same. Now I have seen it. So limit x tending to 2 fx should be equal to f of 2. So what is this? What is this? 4a plus b. 4a plus b equal to 2. So this is the relation between a and b. Done. Similarly, you will do the this question. Wait, let me rub this one. Rub this, rub this. Yes, let's delete this portion. Let's delete this portion. Wait a minute. Yes, let's delete this portion. Now we will do this question. Sixth, see how to do the sixth one. Limit x tending to 0 plus sine greatest integer x upon x. This I've done it with you earlier in the limit problem. So this becomes limit. Whenever you see greatest integer fractional part, convert this into 0, 0 and write this as 0 plus h and 0 plus h. So you will get, see, take the ladder बनाओ 0 और 1 के बीच में. 0 और 1 से ज़्यादा क्या आएगा? 0 आएगा. 0 और 1, between 0 and 1, the floor will be 0. So write sine 0 upon 0 and does not exist. This is limit h tending to 0 does not exist. So the limit does not exist, don't do anything else. No need to show the left hand limit also. Limit x tending to 0 fx does not exist. So fx is not CTS. इसमें लेफ्ट हैंड दिखाने का जरूरत ही नहीं है. एक राइट हैंड ही नहीं एग्जिस्ट कर रहा है तो लेफ्ट हैंड दिखाने का जरूरत ही क्या है? मतलब your right hand is not existing, there is no need to show even left hand. You can save your time in the examination hall. When the limit is not existing, how can you make the function continuous? Limit ही exist नहीं कर रहा है तो function continuous कहाँ से बन जाएगा? Now this point is over. This point is over. Now the next one. Yes, the next one is e to the power of x. This one. Very simple. I did this type of problem with you guys. This not exactly this one, but this type I have done with you. Wait a minute, let me take the full question. Yes, here it is. They are saying limit, let's take the right hand, limit x tending to a plus e to the power of 1 upon x minus a minus 1 upon e to the power of 1 upon x minus a plus 1. Do one thing, take limit h tending to 0, right? This will become 1 upon a plus h minus h, a plus h minus a, and this will also become e 1 upon a plus h minus a. Here it is plus 1 and here it is minus 1. This a will cancel. Limit h tending to 0, e to the power of 1 upon h minus 1 it will become, and it will become e to the power of 1 upon h minus plus 1 it will become. Take, now what you do is that take limit h tending to 0, e to the power of 1 upon h common out. Let's write it below. Wait a minute, let me rub it. Let me rub this one. Let's uh, let's uh, do this one here now. Limit h tending to 0, e to the power of 1 upon h, you take common 1 and this will become e to the power of, I've showed you this method with 1 upon x. I hope you remember. मैंने दिखा रखा है पहले वीडियो में, लिमिट की वीडियो में. इसको h की जगह पे 1 upon x से मैंने किया था. 1 upon h, 1 minus e to the power of minus 1 upon h. They cancel out. Take the limit. This will become 1 minus 0 and this will become 1 plus 0 और 1. मैंने ऑलरेडी ये पिछले वाले वीडियो में 1 upon x से मैंने कर रखा है लिमिट के क्वेश्चन में. बस यहाँ पे x की जगह पे h है, करने का ढंग वही है एग्जैक्टली. बस इसको h में कन्वर्ट करके वो ढंग वही लगाना है. In the earlier video, I did this question with 1 upon x. Here I have used h. The way of doing this one is same as the way I did that one, same. So for limit, similarly when you do like this, your limit x tending to 0 minus would now become e to the power of 1 upon x minus a minus 1 upon e to the power of 1 upon x minus a minus 1. So this will become limit h tending to 0. This will become e to the power of 1 minus 1 upon h, and this will come to be e to the power of minus 1 upon h, 1 upon h, and this will be minus 1 and plus 1, and this will be 0 minus 1 and 0 plus 1, bracket 0 plus 1. Wait. Let me write it in the next line. Let me write this one in the next line. Wait, let me write it in the next line. Yes, just a minute. Let me write it in the next line. Wait a minute. Yes, let me write it in the next line. See, now this will be limit h tending to 0 e to the power of, oh, wait a minute, e to the power of 1 upon a minus h minus a minus 1, and e to the power of 1 upon a minus h minus a plus 1. So this minus a plus a minus a, this becomes limit h tending to 0 e to the power of minus 1 upon h minus 1, and e to the power of minus 1 upon h plus 1. Take the limit. This will become 0 plus 1 minus 1 and 0 plus 1. So you'll get minus 1. Here you got plus 1. So the limit does not exist. Function is not continuous. Wait. The next line we will write. In the next line, we have to write it this. So limit x tending to 0 fx does not exist. So exist. So fx is not CTS. This is the way you will have to do it.